Yes, an 8-exit Wireway can be used to distribute circuits from 8 electrical panels, but there are important limitations and conditions to consider. Firstly, the Wireway must meet specifications for the number of conductors and the ampacity of the circuits. This means ensuring the Wireway is large enough to accommodate the size and quantity of all conductors, including neutral conductors. Secondly, the Wireway needs sufficient space for proper heat dissipation. Each panel should ideally have a separate Wireway section to avoid overloading a single section. Inductors must be properly identified and color-coded to clearly indicate their intended circuit. The circuit should be balanced across the Wireway to minimize phase imbalances. Neutral conductors should be grouped and sized appropriately as well. It may not be possible to fit 3 circuits plus 1 neutral in a single conduit, but 2 circuits plus 1 neutral might be feasible. Consult the National Electrical Code, specifically NEC Table 310.16, for detailed conduit fill calculations to determine the maximum number of conductors permitted in a conduit of a specific size. To accommodate more conductors, consider using larger conduits such as 1.25-inch or 1.5-inch conduits. The Wireway must be securely mounted and properly supported to ensure it can handle the weight of the conductors and maintain its structural integrity. Accessibility for maintenance and troubleshooting is crucial, so the Wireway should be installed in a location where it can be easily accessed. The Wireway must be properly bonded and grounded to provide a safe path for fault currents. As an additional recommendation, branch junction boxes should be considered at strategic locations to minimize the number of conductors running through the Wireway. Using pull strings inside the Wireway will make cable replacement or additions easier in the future. Always provide ample slack in the conductors to allow for future maintenance, repairs, or modifications to the electrical system. To reiterate, using an 8-exit Wireway for distributing 30 circuits from 8 panels is possible, but requires careful planning and strict adherence to the National Electrical Code and all other applicable codes. Proper installation and regular maintenance are absolutely essential to ensure safety and reliable operation of the electrical system. It is important to calculate the total ampacity of all the circuits that will be run through the Wireway. The Wireway must be rated to handle this total ampacity without overheating. The size of the conductors used will depend on the ampacity of the circuits they serve. Refer to NEC Table 310.15b16 to determine the appropriate conductor size for a given ampacity, considering the insulation type and ambient temperature. When running multiple circuits in a Wireway, directing factors may apply to the conductor ampacity. NEC Section 310.15c provides guidelines for directing conductors based on the number of current-carrying conductors in a raceway or cable. Ensure the Wireway is properly ventilated to dissipate heat. If the Wireway is enclosed or in a hot environment, additional ventilation may be required to prevent overheating. All connections within the Wireway must be made using approved methods and materials, such as wire connectors or terminal blocks. Ensure all connections are tight and properly insulated to prevent short circuits or ground faults. Label all circuits clearly at both the panel and the point of termination. This will make it easier to identify and troubleshoot circuits in the future. Consider using a Wireway with hinged covers for easy access to the conductors. This will simplify maintenance and troubleshooting tasks. Before installing the Wireway, carefully plan the layout of the circuits and the location of the panels and termination points. This will help to minimize the length of the conductors and the number of bends in the Wireway. Use a wire fill calculator to ensure that the Wireway is not overloaded with conductors. Overfilling a Wireway can lead to overheating and damage to the conductors. Consider using a separate Wireway for sensitive electronic equipment to minimize the risk of interference from other circuits. If the Wireway is installed in a damp or wet location, use a Wireway that is rated for wet locations. This will protect the conductors from moisture and corrosion. Regularly inspect the Wireway for any signs of damage or deterioration. Repair or replace any damaged components immediately. When making changes to the electrical system, always disconnect power to the Wireway and the affected circuits. This will prevent electric shock and damage to the equipment. Consult with a qualified electrician or electrical engineer to ensure that the wireway is installed correctly and in compliance with all applicable codes. Always follow the manufacturer's instructions for installing and maintaining the wireway. This will help to ensure that the wireway operates safely and reliably. When selecting a wireway, consider the material it is made of. Steel wireways are strong and durable, but they can rust in damp environments. Aluminum wireways are lighter and more corrosion resistant, but they are not as strong as steel. Non-metallic wireways are corrosion resistant and lightweight, but they are not suitable for all applications. The wireway should be installed in a location where it is protected from physical damage. This will help to prevent damage to the conductors and the wireway itself. The wireway should be installed in a location where it is not exposed to excessive heat or cold. Extreme temperatures can damage the conductors and the wireway. The wireway should be installed in a location where it is not exposed to corrosive chemicals. Corrosive chemicals can damage the conductors and the wireway. The wireway should be installed in a location where it is not exposed to excessive vibration. Vibration can damage the conductors and the wireway. The wireway should be installed in a location where it is not exposed to excessive dust or dirt. Dust and dirt can accumulate in the wireway and cause overheating. The wireway should be installed in a location where it is not exposed to excessive moisture. Moisture can damage the conductors and the wireway. The wireway should be installed in a location where it is not exposed to excessive sunlight. Sunlight can damage the conductors and the wireway. Using an exit wireway to distribute power requires a meticulous approach to safety and code compliance, always prioritizing these aspects throughout the entire process. When planning the layout, consider future expansion. Can the wireway accommodate additional circuits if needed? This forward-thinking approach can save time and money in the long run. Document every step of the installation process, including wire sizes, circuit assignments, and grounding locations. This documentation will be invaluable for future maintenance and troubleshooting. When running conductors through the wireway, avoid sharp bends that can damage the insulation. Use gradual curves to protect the integrity of the wiring. Use cable ties or straps to bundle conductors together within the wireway. This helps to keep the wiring organized and prevents it from becoming tangled. When terminating conductors, ensure that the connections are properly tightened to prevent loose connections and overheating. Use torque wrenches to ensure connections are tightened to the manufacturer's specifications. Consider using surge protection devices to protect sensitive electronic equipment from voltage spikes. Surge protection devices can be installed at the panel or at the point of use. Regularly test the grounding system to ensure that it is working properly. A properly functioning grounding system is essential for safety. Use a ground resistance tester to measure the resistance of the grounding system. Consider using arc fault circuit interrupters or arc fault current interrupters, commonly referred to as a size, to protect against electrical fires. A size can detect arc faults, which are a common cause of electrical fires. Ensure the wireway covers are securely fastened to prevent accidental contact with live conductors. Use tamper-resistant screws to prevent unauthorized access to the wireway. Train personnel on the proper procedures for working with the wireway and its associated electrical system. Proper training is essential for safety. Review the electrical plans periodically to ensure that they are up to date and accurate. Outdated or inaccurate electrical plans can lead to confusion and errors. When making any changes to the electrical system, obtain the necessary permits and approvals from the local authorities. This will ensure that the changes are made in compliance with all applicable codes and regulations. Consider consulting with a professional engineer or electrician to review the design and installation of the wireway and its associated electrical system. A professional review can help to identify potential problems and ensure that the system is safe and reliable. Remember that electricity can be dangerous. Always take precautions to protect yourself from electric shock. Work in a well-lit area to avoid accidents and ensure that you can clearly see what you are doing. Keep the work area clean and free of clutter to prevent tripping hazards. Do not work on electrical systems when you are tired or distracted. Fatigue and distractions can increase the risk of accidents. If you are not comfortable working with electrical systems, hire a qualified electrician to do the work for you. It is always better to be safe than sorry. Proper planning is key to efficiently distributing power from multiple panels using a wireway. By carefully considering factors such as conductor size, ampacity, dirting, and grounding, a safe and reliable electrical system can be established. Always consult the NEC and local codes to ensure compliance. With careful attention to detail and a focus on safety, the wireway can be a valuable tool for power distribution. Always prioritize safety and consult with qualified professionals.